In last session, we discussed about unions, different types of unions like union and union all, and also subqueries. And I'm repeating the same. Subqueries are very important. You will be using it in daily life in projects. So practice it as much as you can. Don't neglect subqueries, and you can expect a lot of questions from subqueries to in SQL Server. Now, in this session, let's see a couple of things like intersect, except, and table expressions. So we're going to cover these three in today's session. First, let's start with intersect. So you might have heard this word in your plus 2 or 12th class, somewhere in 12th or 11th class, intersect. So what this intersect will do? And to demonstrate the same, I created two tables. One is employee info and another one is employee info 1. And I inserted some data into the tables. You can see it has 1, 2, 3, 4, 5, 6, same in both the tables. 7th record, a little bit change. The 7th record, the ID is interchanged, 7th and 8th and 8th and 7th here. So the IDs are interchanged. It is not same record, I can say. It is not exact record. Let's see how to execute, how to use intersect. Select star from employee info, intersect the select star from employee info. The same rules what we have applied or what we have read for union, the same rules will apply here for intersect. The same number of columns should be there and same type of data type for mapping columns. So the same rules will apply for intersect too. So if I execute this query, you can see it is getting only the matching records. All right. In both the tables, there were couple of different records. What are those records? 7 and 8. These two are changed because of the IDs are not. These two are not written. Why? Because the IDs are not proper. If you see the 7th ID, employee ID 7 is not Pawan. It's Sukumar here. Whereas here, the employee ID 7, it's Pawan. So this record is not available here, and this record is not available here. And in the same way, this record is not available in the first table and this record is not available in the first table. So what this intersect will do is intersect will get the matching records from both the tables. So if you want to get only matching records, then you can go for intersect keyword. And it sometimes you need to get only matching records. What are the matching records from both the tables? You need to fetch data in few cases. So in that case, you can go for intersect keyword. The next one is except. It is just like English. What this except will do? Except means except a particular guy. Anyone can train me except Rupesh. Why? Because he's not a good trainer. So in the same way, except work for two tables, and this is how it works. Let me show you an example. And again, the same rules will be applied, just like what you have read for union and union all. If you write an except statement, what it will do is it will execute this query and it will get the records from the first table, okay, from this table, which is not available in the second table. So if you see both the tables, these two records, and there are two more records. Let me show you that data too, so that it will be clear for you guys. So I'm executing these three queries now. The first one is except part. Except part what it will do is it will take the first query data set, that is this data, and it will check with the second query data set. Every record, first record, is it available or not? Yes, it is available here. So ignore it. Second record, it is available or not? Yes, it is available. Ignore it. Third record, fourth record, fifth, sixth, everything is available. But seventh record is not available in the second one, so it is showing the seventh record. You can see 7 Sukumar, Hyderabad, AP, and India. In the same way, the eighth record here is not available in the second table. There is eighth record, employee ID 8, but the name is different. It is not Pawan, just like in the first table. It is Sukumar. So these two records are not available in the second table. That's why it will get everything except, it will get all the records which are not matching. with the second SQL statement given in the the query. Now, if you interchange these two guys, I've given employee info first, info one as the first query table, and employee info as the second query. If you see, it is giving 7 as Pawan and 8 Sukumar. These two records are from the second table, that is employee info table. Now what will happen is employee info 1 table will be checked with employee info table. So first record present, yes, 2, present 3, 4, 5, 6, everything is present, but 8th and 7th are not matching with the second query in the second select statement in the query. So it retrieves these two data. So this is how the except works. Except is like if I take the pen, this is your first one and this is your second one. This is the matching record. The one in the middle is matching. Okay. Except means it will give only the first table stuff. Only this guy, the one which I am highlighting. So it will retrieve only this data. But if you go for intersect, this is your first table and this is your second table. Only the matching, the intersect records, which is common in both the tables. And let's say this A table is the first one, first select statement, and B is the second one. There will be matching records. Only matching records will be fetched. So this is how the intersect and except works in SQL Server. So this is not frequently used keywords in SQL Server, but I won't say that it is never used. It depends on your requirement. Sometimes you may need to use these keywords, so better to have a knowledge on this. Now let's see about table expressions. Very important as part if you think about cracking an interview in SQL Server. You can expect a lot of questions from table expressions. What are these table expressions? Let's see brief about table expressions first, and then we will jump into the examples for each kind of table expression. So, table expressions. Table expressions is nothing but a select statement where the table is expected. Where generally the table is expected? Table is expected in these kind of cases. Select star from table name, right? This is where you will provide the table name to fetch the data. So instead of providing the table name, if you provide a select statement, then that is called table expressions. So instead of table, you will use select statement. These are very close to subqueries. Yesterday we discussed, in last session we discussed about subqueries. These are very close to subqueries, but the only difference is subquery will have inner query and outer query. So the inner query will be passing value to the outer query, and sometimes outer query will be passing value to the inner query. But here these two are merged. There will be no inner query, there will be no outer query. These two are merged. You can see this is your select statement, and instead of some table name, you will provide one more select statement. Can you say which one is outer query and which one is inner query here? There is nothing like that. These are merged one. Okay, these are called table expressions, and this table, what you are going to create using table expression is virtual. For example, select star from products. Let's say I've created this one. This is a table expression which is virtual, which will not be created, which will not be allocated with physical memory in the SQL Server. This is virtual and will exist until the query executes. After that, it will not be exist. So it's a virtual one. So this is about table expressions, and there are two types of table expressions mainly. One is derived tables. Spelling is wrong. Let me correct it. D-E-R-I-V-E-D. And the next one is CTEs. So these two are very important. People, you will get a lot of questions on these two in SQL Server interviews. So what is meant by derived tables and what is meant by CTEs? We are going to see in a couple of minutes. So the first one, derived tables. Derived tables is nothing but the one which I showed you here as an example. You can see instead of a table name, you will specify a query. You will specify a select statement, and the outer select will be executed on the output of the inner select. So if you see this is the derived table. This is an example of the derived table. First, this inner query, this particular query will be executed. That is table expression. We call it as or derived table, in other words. Once it is executed, the second query, the outer one, will be executed on the output of this one. If this guy fetches 5 records, and this guy will be executing on the 5 records. So if I take an example, you will get better idea on this particular thing. So to take an example, let me go to another database. This is not the best one. So let me go to AdventureWorks database. So what my requirement is, okay, my requirement is to get the products where it is not null. Okay, for example, select star from, instead of select statement, I am giving select star from products. Sorry, dim product. Where what is the column? Color is equal to black. So if I execute this particular query, first the inner one will be executed and it will retrieve some records. Let's see how many records it is going to fetch. It is fetching 132 records, and then the outer query will be executed. There is some problem. Let me see what the problem is. So that's a problem. I have to give a name here for this. So if you observe this query, at first the inner query is executing, and the output on this one, if you execute this, it is retrieving me 132 records, and then the outer select will be executed. What is the use of this? I can directly use this. I can directly execute this. What is the use of this particular table expression where I can use this? Let me show you an example here for that. Before going to that, let me see whether I have any date related columns. Then based on that, I can demonstrate the example in a better way. I'm taking date wise sales. Okay, I'm writing a query for that. Select star from dim time. I'll call it as A, inner join, fact internet sales. I'm calling it as B on A dot due date key. Sorry, A dot date key. What is the primary key column in this one? I don't remember. Time key is equal to B dot due date key. And here, instead of getting all the data, I'm getting A dot, what I can take, full date alternate key, comma, B dot sales amount. So if you see, what I'm doing is I'm getting the date as well as sales amount for based on due date, when the dues was clear. So on this particular date, this amount of dues was clear, and on this particular date, this amount of dues was clear. Now I want to get, instead of date, if I want to get year, what I have to do? I can use the year function for this, right? Like year of this particular date will give me the year value. I will name it as year. Let's see. You can see it is getting me the year. The year function is available in time functions. We already discussed as part of our SQL Server basics concepts. So the year function will give you the year when you pass a date column, and this is a date column. It is giving me year, and I'm showing the column name as year and the sales amount. Now this query is absolutely fine. Now my requirement is I want to group based on this year. I want to take the sum of sales amount based on the year. You can see there is 2001 repeating so many times. I don't want to show so many times. I want to get the aggregated data. What is the way to get the aggregated data? The only way is using group by statement. Let me copy the same year of so and so and sum of sales amount as sales. And what I have to give in group by? Group by year. I want to group by year column, and if I execute this, it is saying invalid column year. Why it is saying invalid column here? This is to explain this part. I showed you what is the logical execution of the select statement. What is the logical execution of the select statement? First is from class, and then where class, and then group by, and then having, and then select class, and then order by. So this is the logical order, logical execution order of a select statement. Now I'm taking group by. Where is this group by? This group by is the third one in the execution cycle, and from class is the first one. So it will get the from table dim time and from table fact internet sales all the columns information, and it will apply the where condition if there is any. There is no where condition, it will not apply, and then it will come directly to the group by. By the time the group by looks for this year, the select is not yet executed, the select is not yet ready. So that means the select is not yet the select is not available to use it in the group by statement. So that is why we are getting this issue. How to overcome this issue? How to solve this issue? Let me show you the same. To solve this issue, instead of using this part, okay, instead of using year column, which you have given as an alias for this particular function, year function of a date column, you can directly give the complete function whatever you have used. So this is one way of solving the issue. So you need to know the order, how it executes logically. Based on that, if you understand this very well, then you can easily understand why it was throwing error when I have given the column which I have defined as an alias to the year function. Okay. Now this is fine. This is a workaround. I can easily work based on this. But this is not the ideal way. This is not the best way of doing. I mean, using the function again in the group by. So it will be executed once here, and it will be executed once. It executes twice, which is of no use, right? It may lead to performance issue. You don't need to execute it twice in real. So what is the next workaround? What is the next other best way to achieve the same result? To achieve the same result, you can go for table expression, that is derived tables. Let me show you how we can do that. So if I take this query as is, okay, and if I remove this sum part, the output will be year wise sales. If I make it as a derived table in the sense in the from class where the table is expected, if I make it as a derived table, you can see now the magic. Select, you can call whatever the columns that are present in the derived table. First the derived table will be executed, right? This will be executed first, and the table will be ready by the time the outer select executes. So I can use a dot, or let me give some alias. I'll give C. Okay, I'll give C dot here should be available by the time the outer select executes, and C dot sales from this particular derived table. So if you observe this query, first the inner will be executed and this part will be executed, and a table called C will be created with two columns. One is year and one is sales amount. So in the outer table, what I'm doing is I'm just calling that values. I'm taking the year value, I'm taking the sales value, and I can use group by year. Now why? Because the year is available. The year will be available when the inner query or when the derived table query is executed. If I execute this, oops, sorry. Yeah, sales is not valid. Why? Because I have here in the group by statements, and all the columns which are not present in the group by should be should have any aggregate function, right? So let me give sum as sales. Now let me execute the query. It is working perfectly fine. So the logic here is the inner query will be executed, that is the derived table query will be executed, and the data will be ready, and the table will be ready by the time the outer one executes. So I can directly use the column year and use the column sales and use the column here in the group by. But here the case was different. By the time this select statement, by the time the group by statement executes, the select was not ready. So this is one advantage of having derived tables. So there is, you may need this concept. You may use these concepts in your real-time projects. Why? Because most of the cases you will have data years in. So you will have the data in the form of dates from which you have to fetch the data year-wise, month-wise, or sometimes quarter-wise, and group by quarter, month, and year. So in those cases, these derived tables plays a very good role. Just like subqueries, you can nest these derived tables also. For example, this is a select statement with one derived table, right? You can see this is the derived one. And here, instead of this date dim time, and instead of this inner join and all, you can have one more derived table like this. It's all based on your requirement. You can have one more derived table. There is nothing wrong. So this means nesting of derived tables. You can nest derived tables just in this way. Where the form table name is expected, you can go for a derived table. And one important point is about subqueries is how many levels you can apply the subquery. Yesterday we discussed about subqueries, right? One query inside the another query. So like that, how many levels you can go for. The Microsoft has given provision to go for 32 levels like that. You can create a subquery with 32 levels. But remember, it all depends on your memory. If the memory is not available and if you're running a big query, huge query, which is dealing with some millions and millions of records, then the query will be errored out. So the limit given by Microsoft is 32 levels. You can create subqueries with 32 levels by keeping memory in mind. Okay, memory should be available in your system, or else if memory is not available to process a particular query, then obviously the query will be errored out. So just that's a point to remember. That's an important interview question. People may ask how many levels you can go for in a subquery. So you can easily answer, right, if you have a basic idea. That's why I told you that. Now, coming back to this, we discussed about the derived tables. What is the next one? What is the next type of table expression? The next type of table expression is CTEs. This is pretty famous one. CTE stands for Common Table Expression. Common Table Expression is nothing but a temporary named result set. That means a temporary table or temporary result set with some name. Okay, that you can refer in your select statements. So there will be a temporary set created just like here, just like in the derived tables. What the derived table will do? The derived table will create a temporary table kind of thing on top of which your outer query will be executed. In the same way, CTEs, it will create, it's like a temporary named result set, and here the syntax is different. Let's see the syntax and all. It starts with keyword, with name of the CTE, what name you want to give, and columns if you want to specify what are all the columns, column 1, column 2, column 3, and so on, as you will write a select statement. Select statement. Okay, and you will write your outer select statement, select star from the CTE name, whatever the name you use. So if you see here, the select statement, this select statement will be executed and will be assigned to this CTE. Okay, and you can use this CTE here in your table, in your select statement. So it is just like a derived table. Why I need a CTE here? What is the advantage of having CTE here? Let me take an example to demonstrate the same. So first, let's go for some theory here. There are two types of CTEs. One is non-recursive, another one is recursive. Non-recursive and recursive, the difference between non-recursive and recursive is recursive which references itself, which will have self-reference, whereas non-recursive, it will not have self-reference. So you don't understand what is self-reference and all here. So first let me take an example for a non-recursive CTE and then jump into recursive CTE, which will have self-reference. So let's take a simple example. I have a query like this. Select. Let me see what are all the columns that are present in the product, dim product. So if you see here, safety stock, recording point, list price, days to manufacture. I'm looking for some useful column here. Safety stock, list price is all null, or do I have any value? Let me check that. It is all null. Product key. There is no much information, required information in this particular table. Okay, let me do one thing. I want to get all the products. Okay. Remember, try to understand the requirement. I want to get all the products whose sales or whose record point is greater than the average of the record point. If you take the average of this record point, this particular column, if you see this particular column, you'll get some value, right? So I want to fetch only those records, those products which is having the record point greater than the average of it. So first, what is my requirement here? Select average of record point. Invalid column name. I think it's something else. Recorder point. Okay. So average of recorder point is this one. Okay. Now what is my requirement? Select star from dim product where recorder point is greater than this one. So this is how you can achieve this requirement using, again, the spelling mistake for the recorder point. Let me copy this. So this is how you can achieve the same using what is that? Subqueries. Now let's try to implement the same using CTEs, non-recursive CTEs. How to do that? So first, let me create a CTE with, I'll name the CTE as record point, and I'm not specifying any columns. It's not mandatory. If you don't specify any columns, the insert query columns will be taken. So here I'm taking select what is that? Average, right? Average of recorder point. I'll take the same query which is available here. As the recorder, the alias column, and this ends the select statement. Now let me go for my outer select. I'm taking the table here, select star from dim product where recorder, I'll copy the spelling, I'll copy this column. I'm doing it. Is greater than, you're going for the value. The value you're going to get here. Select star from the table. The table is nothing but the common table expression name. Now let me execute it. Guys, my apologies. I have given a wrong example. This is not the best way of taking the, explaining the CTE, non-recursive CTE. Let me go for a better example. Okay, I've done a mistake. This is not the best way of doing the what I can say CTE to demonstrate the example for CTE. Okay, I'm going for this example. I'm creating a CTE. I'm naming it as sales. The table name will be sales. As I'm taking a select statement here. Select product key, comma, sum of sales amount as sales from fact internet sales. So I'm taking the product key and sum of sales amount from the product sales. As one is an aggregate column, what I have to do? I have to go for group by product key. So what this guy will do is, this guy will return only each product wise total sales. I'm getting this information, and this information will be assigned to the CTE name that I have given, that is sales. Now if I execute this, I can refer now. I can use this table, the CTE table, here in the outside query. We call this one as a outside query or the end query, and this is called as CTE query, common table expression query, the query which will load the data to the common expression. So if I go for here, select star from sales, you can see it is getting the same data. I can refer to this table, the one which I created using CTE. What is the difference between derived table? I can do the same using derived table. It is far easy than this using derived table. For example, let me go for the same. Select star from, if I take a derived table instead of table, it will do the same job. See, I'm copying the same query which I have taken for CTE, and if I execute this, it will give you the same result. What is the advantage of having CTE here and compared to the other table, the derived table? Let me show you an example here. If you need to use the condition in two places, let's say you have to use this same condition in two places. Select star from so and so, inner join, a same subquery. What you have to do? You have to write like this, right? Select star from the first query, inner join the second query, a dot a, on some condition, a dot product key is equal to b dot product key. So what it will execute? It will execute those variables and it will join and it will fetch the data. So here if you observe the query, the derived table query, first here it will be executed this particular query and assigned to a table A and get the data for the select, it will get the data, and the same one will be joined with the same query again and go, having the condition a dot product key is equal to b dot product key, that is inner join condition. So to achieve similar kind of requirement, if you see it is executing twice, here it will it executes once, here it executes one more time. This is a performance issue. If you have such kind of requirements where you have to execute the same thing couple of times, then it's better to go for CTE. So you have a CTE here. Select star from sales, inner join, again sales. But here I'll give the name as A. Here I'll give the name as B on A dot product key. Sorry, A dot product key is equal to B dot product key. If I execute this, you can see the same data is coming. So whenever you need to execute a particular select statement more than once, then it's always better to go for CTEs instead of subqueries or derived tables. So let me tell you one more example. Select star from fact internet sales. I want to get all the fact internet sales data where sales amount is greater than, I'm taking select average of sales amount from fact internet sales. So what I'm doing here is I'm taking the average and checking if the sales amount is greater than the average of the sales amount, then get the information. And if I have one more uncondition, and tax amount is less than the same condition, average of the sales amount. If the tax amount is less than the average of sales amount and the sales amount is greater than the average of sales amount, then fetch the information. This is your requirement. Let's say you are executing the same query twice, here once and here once. If the table is having huge data like millions or billions of records, then the performance will be very big hit here. So for these kind of data, what you can do is you can go for CTEs, which will help you. Here the query will be executed once and the data will be assigned to this particular CTE name, and you can use the CTE name in your outside query or the end query. So this is called non-recursive CTE. Why? Because this query is not dependent. This is not a referencing. It is not having self-reference. So I'm once again my sincere apologies. I was not in mood. I was thinking about something else while explaining the non-recursive CTEs. So this is the final one. If you see an example, the outside the tape, the CTE name. This is the name of the CTE. What you are gonna refer as in the outside tape, outside select statement. And the select statement, what you are giving here will be the final one, the CTE select statement. This output will be assigned to this particular CTE name, and the CTE name will be available for your reference. And you can have more than one. This is one, right? Sales. I can use a comma separator, and I can have sales underscore temp, one more CTE, as I can have the same select statement or different select statement. It depends on your requirements. When I just copying the same select statement, don't think that you have to go for same select statement. Now, even this guy is ready for access. Sales temp. Let me execute this, and you can see it is executing fine. Now I have two CTEs here in the same query, one with the name sales and another one with the name sales temp. If you want to provide the columns, for example, if you provide the name as key, comma, another one is sales amount. These are all the two columns that I'm going to retrieve from the using the select statement. And if I execute this one now it is already started showing. You can see a dot something is not able to find. Right? I'll name it as prod key. So this should be prod key. Whatever the column name I specify next to the CTE name, this will be the final one when you refer it. They're not the query returned columns. The columns, whatever you specified here, will be the final one. And if I execute the complete query, now you can see it is retrieving as product key and sales amount here. And this is the default column names, whatever present. I'm not changing anything for the second CTE. Like this, you can have more than one CTE in a query. So this is about non-recursive CTEs. This inner query is not dependent on the same. It's not having self-reference. Now, if you're clear about this, let's jump into the recursive CTEs. How to go for recursive CTEs. Recursive CTEs is mostly useful whenever you want, whenever you are working with parent-child hierarchy data. I hope you still remember the parent-child hierarchy data which we discussed in SSAS. When like manager and employee, it's a parent-child hierarchy, right? Self-referencing one. So let me show you how to create a recursive CTE. So with, I'm giving the name of the table as emp details, okay, employee details. I don't give any column names, as here I have to give the select statement. So while giving a reference, self-reference, while going for a self-reference CTE, that is recursive CTE, you have to be very careful. How you have to write is, first you have to get the first level information, like select star from dim employee. Okay, now I will go for employee key, the key column, comma, manager or parent employee key, fine. And third thing, I'll go for first name, comma, last name. I'm going for these two columns, and I'm adding one more column as level. Okay, so I'll show you, I will explain you why I'm having the extra column 1 as level here. Okay, this is the select statement where parent employee key is null. So let's see what this query returns. This query is returning one employee, that is Ken Sanchan, who is the topmost level, the first level, like CEO of the company. This guy has no manager. He is the top level guy. That's why I pull the first level information. Now, how to have self-reference, self-referencing, how to have it. So to do that, you have to go for union all and the same column list, select star from employee. Again, I'm going for the same, sorry, dim employee. I'll name it as A or E, which will be easy to, or which is a very relevant one. So here I'm calling the same E dot employee key and E dot parent employee key, E dot first name, E dot last name, and here I'm using the table or CTE which is created with the same query. This is called self-referencing. I'm not going to use some external table here. I'm going to use the same CTE table that is called self-reference. So employee details, I'll call it as D on employee, sorry, E, right? E is the last name. E dot employee key is equal to D dot parent employee key. And here I'm going for level D dot level plus 1. If this is the first level employee where he is null, this guy will be increased to 1 level. So it will be self-referencing. It will go to each and every level and finally it will retrieve the complete employees data in the hierarchical order. Let me show you that one too. I'm sorry, here it should be parent, I think. Parent employee key, and this guy should be employee key. Now the select statement is ready, which is having self-reference. This is your first query, and the same query using union all, this guy is referencing to the same CT. That is nothing but the output of this one is referring in the same query. You can see that D is the same query. Now here I am calling the select star from employee details. If I execute this, first let me execute and then I will explain each and every part of this query. First let me execute and show you what it is gonna retrieve. What it is retrieving is, first it is getting the first level. This guy will be retrieved. Okay. Observe it very carefully. This is very tricky one. First this guy will be fetched and it is showing in the first level, right? Now this guy, while this guy referencing to this employee details, this guy will be having data about this guy. The first query output will be already available in the table with employee details, right? Now when this query references to this by using inner join and getting parent employee key from these tables and employee key from this table, what is the employee key that is present for this table? It is 112. So it is nothing but this value will become 112, will be replaced with 112, right? So I think you are confused. Let me explain you again. So first it will execute this part and this will be assigned to this table. So after executing this, the output will be assigned to this one, and then when this select statement is executing, it will take the employee details, that is the first record will be assigned to this employee details CTE. So now this first record will be joined with employee. Now it is joined with employee table. You can see dim employee is joining with the data that is present in the employee details, that is nothing but the first record which you are seeing here. On the condition this ID is equal to the manager ID, the parent employee ID of the employee table. So these guys, this employee ID as manager means all his reportees who are all reporting to this ID 1112 will be fetched by this union, and in the same way the data will be increased here and it will go to the next level loop. It will continuously loop and finally it will go through all the levels and get the data of the parent child hierarchy. That is why I have taken level as 1 here, the default one, and here I'm increasing the level by 1. So whenever it loops, it will increase the level value by 1. First it is level 1, and then it will become 2, and then it will become 3, and so on. So you can see this is the third level, and this is the fourth level, and so on. You will get 5, 4. You can order it. If you want to order, you can order based on the level. So if I execute this one now, you can see the data in one level. This is the first level guy, which we will get with the first query, and this 2 level data will be fetched by executing this query first time, and then the third level will be fetched by executing the same query second time, and fourth level will be fetched by executing the query third time, fourth time, and so on. So this is how you can do that. So now instead of specifying star, I'm taking employee key, comma, parent employee key, comma, first name plus, I'm giving some space, last name as employee name. So this is better, right? To show in one column rather than 2 columns. So it is saying invalid object. Why? Because I have not selected this complete query. You can see now this is the employee key, and this is the parent employee key, and this is the employee name, and this is at this particular level. You can do one more thing here. You can use subquery. You remember subquery, right? You can add subqueries in the name of columns. Instead of this parent key, you can show the manager name. How can you do that? You will get some parent key. It will be null, 112, and so on. So the subquery will be like this. Select first name plus last name as it is plus, it is not equal to manager name from, let me drag it to the next line so that it will be fully shown. Select first name plus space plus last name as manager name from dim employee where employee key is equal to the parent employee key. Whatever the parent employee that will be fetched as part of this result set will be checked with this employee ID, and it will get that first name and last name. So for example, let's say this 112 will be replaced here, and it will be mapped with 112. That means this key, and get the manager name, that is Ken Shanchet should be written. Let me execute this and show whether it is returning the data properly or not. So I'm using a subquery here. This is how you can make use of the subqueries and all. Oops, bullshit, it is not getting the data. Let me see what the problem is. It is returning null for everything. There should be some problem in the query. Let me see that. Can you go for a guess what could be the problem here? The problem here is, I'm saying employee key is equal to parent employee key. What it will do is, it will take the parent employee key from the dim employee. Why? Because dim employee has employee key as well as parent employee key. What I have to specify is, get the parent employee key from the employee details CTE, whatever the value that is being written by the CTE. Now if I execute this, it will be checked with the parent employee key of the CTE and maps the data with the dim employee table and returns the manager name. So this is how you can create the hierarchy. This is how you can specify the manager and employee hierarchy at different levels. And here, if you observe, you are able to get the level also, which you can use while defining your parent-child hierarchies. This is very helpful one. Using this level, you can color code in a different way, and so on. So this is about recursive CTEs, common table expressions. Common table expression means you will have one table and which will be used in many places. Like I showed you an example while discussing non-recursive CTEs. And this recursive CTEs is very tricky, so you have to be very careful, understand the concept, and practice as many times as possible. So guys, this is about intersect, except derived tables and common table expressions and different types of common table expressions. So that's it for today's session, and we'll catch you in next session. Thank you.